music. I think the settings from yesterday worked fairly fine, didn't it? Now, where did I put all the overlays? That is a good question. I think I found it. There you go, I found it. Okay, cool. So all we have to do is open Spotify and find some free music, hopefully. Let's look at the queue. Okay, cool. We have some lo-fi music. There you go. Hopefully I can still talk some more as well, because it's not as late as yesterday. Cool. Let me just listen to the audio and hopefully it's all working very nicely. Let me just listen to the audio and hopefully it's all working very nicely. Let me just listen to the audio and hopefully it's all working very nicely. Okay, cool. Let me just listen to the audio and hopefully I was gonna... Okay, it seems to be working fairly well. Put the music back and let's get to some coding today. So the issue that I have here today is that I'm not sure if there's anyone watching this or if they will ever watch, but I have a C drive currently on my laptop that is essentially running out of space, as you can see here. And one of the main contributors to this, I'll say probably a good 20 to 30 gigs of that is the WSL installation. So basically, for those who don't know, you can use a Linux terminal in Windows using the Windows subsystem for Linux, and that installs on the C drive by default. But my D drive here, which is it's not an SSD, but you know, it has a lot more free space than my SSD. So because I don't operate a lot of computationally intensive stuff on WSL, I might just move it to that because it'll be easier. It's not going to slow things down too much, hopefully. So yeah, I mean, let's follow a guide and see if we can get through this. The first thing I'm going to do is obviously open the WSL installation. Let's just have a read here to see what we actually need to do before we do anything. So okay, C drives running out of space, which is my case. We can move our WSL2 to a different drive in a few steps. Let's see how good this is. So I need to get my username. Why, I don't know. Let's have a look. And we need distro name, okay, which I can get. Knowing the username and the Linux distribution and confirm. Okay, so let's just save those. I mean, I know my username and the Linux distribution that I'm using, but just to make sure, we're just gonna put that somewhere. Okay, so my user is my name. And my distro name. And I believe I have to look at here, WSL. I can't remember the command. Get my dog to calm down here as well because she's very upset. Anyway, so going back to this, it's list of variables. Okay. Okay, so this is what we have, the distro name. Let's just save it here. Why did it not copy? I don't know. Didn't copy most of it. Just a second. Vinny, hey, come, sit down. Come, hey. There you go. She's a bit more quiet now. Okay. So with that information, what do we do? Well, the next step is to move. Be done on PowerShell. Okay, cool. First, we need to close all the terminals that are using WSL. We've shut down, I believe. Yeah, as it is. So all we have to do is just type in WSL, and actually this font colors here are really weird. You can't see because of the transparency as well. But it is. I am typing the whole command. Okay, so we make a directory inside the D file, right? We do have WSL in there already. What is that? What's in Ubuntu? Does this work? No. What does this show me? Okay. Let's analyze this file here just so I can see. 15 gigabytes. Is it already in there? Oh. Maybe I did export this before, but I have never actually moved the D drive, so maybe I've already tried to do this. So let me just make a directory called WSL2 and then we'll put it there now. And let's shut down. I've already shut down, right? Yeah. And then we're going to export everything to the D backup. Okay. The backup directory. And just so we're clear what I'm typing, what do we have here? Okay. So this is going to be essentially WSL2. There is no distro name. Okay. That has to be, of course, the distro name that we saved before, which is Ubuntu 2004. That's the version of Ubuntu I'm using. And this will take a huge amount of time, I believe. It's probably going to save a file that's about 20 gigabytes big. That's what I estimate. Yeah, this will take a long time. But, you know, we can wait. I don't actually have any indicators on OBS to say how many people are watching. I know it's probably 0 now, but let's see. Yeah, 0 people, but that's okay. I'll leave that open on another tab here. Okay. Oh, there you are. Thank you, man. I never actually asked you what's your name. I think we connected on LinkedIn, but you know my name, Mateos. What's yours? You're definitely my one of the biggest fans here of the channel, so. Kelv. Okay. Welcome, Kelv. Let's see if Miguel said he might join as well, so we might do some audio programming in a bit, because the guy was interested in looking at how you can do audio programming with C++. So that's the plan for today. Right now, I'm just backing up my Linux distribution to a different drive, as you can tell by the description. Because it's way too fucking big. Look at this, I've got 20 gig left on my C drive, so I'm going to move it to the D drive. And I hope things don't slow down. So let me actually start getting post audio stuff up, because that's what we're going to be using today. Ooh. So I'm not sure if you've seen it. Post Audio is a library you can use to do audio programming in C++. So you can output audio buff. You can have audio buffers that will output audio in real time, and you can create things like, yeah, just like simple songs, or you can read in MP3 files, WAV or WAV files, and then play those back as well. But the plan today is just to get a simple application that will play some notes, basically. And then we can maybe do a little song. You used to customize your prompt on Ubuntu. People love that. Oh, yeah. So, yeah, I mean, I can show it to you in a bit, but it's something called Z-Shell. You know, very easy to install. And yeah, I mean, you can even use it on Windows as well on PowerShell. I'm not sure if you use both of Windows and Linux, but it works for both. What you want to look at, if you want, I'm not sure if you've already done it, so is my Z-Shell. This is what you need to install. They have a really good guide here, so you know all you have to do is run the script. And there's many themes you can check out. So yeah, it's quite cool. Like, I think the theme I currently use is called YS, right? There you go. This is the one I use. So it's very simple, very minimal. So, but you know, there's way more like advanced ones with like really good Git integration and etc. But yeah, that's a little bit weird on Git integration is a little bit weird on WSL and Windows, because the Git essentially has to access all the files in the file system, so it can become very slow, because when WSL sort of calls files in the Windows file system, which is a different file system, it translates everything, so you know it takes forever. So I basically took you know the very minimalist theme here, and then remove the Git integration. As you can see, I have no like Git master or whatever, but most of these themes will already have all of that for you. Starship, might take a look at that one thing at a time. Yeah, Starship, is that a theme or is that a, I guess it's a different shell manager, right? Starship, I'm actually interested in that. Let's have a look. Oh, okay, so it is a theme, Starship cross shell. Let's have a look at what it does. Yeah, it's very minimalist as well from the looks of it. So it works on Fish, which is a different terminal. Actually present in the Manjaro distribution, I believe, for Raspberry Pi. I installed one called Sway and that had Fish in it. I quite liked it. PowerShell, so it does work on PowerShell too. That's good. Yeah, I see. I really like these minimalist themes. You know, as long as it's clear what you're doing and where you are, that is good. I mean, for me, when you have a theme that has many different things at the same time, and your prompt ends up taking the whole line of the terminal, then that's where I draw the line. But yeah. So cool. Let's hope we get some more people here today, maybe from the channel. And we can start doing some code reviews, and you know, if there's anything you want me to look at as well, Kel, let me know. I'm happy to look at it together. I'm just fucking waiting for this. Oh, sorry for the language. I'm waiting for this backup to be done so I can actually start the work today. But yeah. You know, what's interesting about these managers, for example, my Z-Shell, is that the code is very easy to read. And, you know, anyone can contribute. I think this one, for example, is mostly shell, so you can take a look at it, and then if there's anything you want to customize, you can push it back to the repository. So, but yeah. That was a new terminal. I can't remember what it was called now. From, oh shit, new terminal, or new shell, actually. I think it's a new shell. Yeah, new shell. I'm not sure if you've heard of it. It looks quite interesting. So it's supposed to be a kind of like you know, actual shell, I guess. And it has certain ideas from PowerShell as well, which I really like. But it seems to be a very sort of feature complete at the moment shell. That's probably gonna, hopefully, it's gonna take over in the future, because it looks very neat. Like, it's all structured, the output you get from it. So kind of like what you get in PowerShell, but it has you know, a lot of ideas that come from the Unix shell side of things as well. So if you ever want to take a look at this, I mean, I remember looking at the project on GitHub and finding it very cool actually. So it seems to have a lot of contributors nowadays. So maybe one day I'll actually install it to test it out. But yeah, that's one of the things I plan to do in the near future. You know, try this thing out here. But yeah, I mean, syntax is completely different to shell sometimes, and obviously absolutely 100% different to PowerShell, which is at the end of the day has a weird syntax. But yeah, I mean, it looks very neat, and I like the output style here. And yeah, let's see. Is it actually hard to install? Because I might take a look at it for maybe a future stream now. So it comes, you can install it on Windows and you can install it on Mac OS. There's no Linux. Oh yeah, Linux, Mac OS, sorry. So I guess if you do sudo apt to get new shell, you'll be able to do it if it's in the Ubuntu repository or like a pacman install or something. Or maybe snap install, I don't know. Yeah, you can see the packaging status. So for Arch Linux, it's up, which is cool. So that's Manjaro is up as well. So it is there on the package manager. Is it on Debian by any chance? Where is Debian? Where's D? Oh, U for Ubuntu. Where is it? I can't find it. So yeah. No, maybe it's not up for Ubuntu, yeah. Alpine Linux is there. I mean, if it has all these distributions for Linux, then I assume it's going to be on Ubuntu as well. I installed Dome Emacs a couple of years ago, but I haven't had the time to properly test it. You seem a lot, but once you get grips to it, yeah. So the thing about, you know, Vim, Emacs, or things based on those is that once you learn, and they're very productive. Like I'm a Vim kind of guy. I use it on like Visual Studio Code, or if I'm on Linux, I use it like just Vim itself, and I tend to customize it with like plugins and stuff. And yeah, once you learn a few commands, it's very, very neat. You can write code very, very fast, and just things like copying and pasting code or repeating code over and over again becomes really, really easily with these text editors. So it's definitely worth learning. I know a lot of people say it's hard, but I mean, once you get to grips with it, as you said, then it's good. Have our installation? No, yeah, so it's still going. So I assume it's gonna take quite a long time here. But yeah, I mean, let's go back to power. Sorry, let's get out of these shells here, and let's take a look at Pulse Audio, because this is what I'm gonna use, and I've used this in the past. I started writing a audio visualizer, you know, kind of what you get with like early Windows, like a media player. So if you remember Windows Media Player back in the day, you're from Brazil, right? So we had Windows XP back in the day. It was quite popular in the early 2000s, and that had a media player, and they had all sorts of audio visualizers, and that's what I was trying to do. And I began using this library here to actually do the audio stuff. But yeah, I mean, ideally we want to use a project manager, a package manager such as Conan or VC Package, and let's see where it's available first. VC Package. So these are the two main package managers for C++. I'm sure you know what they are, right? So it just brings dependencies into your project very easily without you having to copy and build things and put headers in places. Conan's the next thing I'm going to learn how to use. Yeah, Conan is good. I've used Conan for like a couple of years in my previous job, and I still use it nowadays sometimes. One of the drawbacks is that it is written in Python though, so you still need Python to basically compile all your code. However, VC Package, which is the Microsoft one, and I'm not saying this because I work there, does seem to not need as much stuff as Conan. And from what I can see in the repositories, it seems to be a bit better, not better developed, but it has more momentum, more people contribute to. I need to finish some CMake stuff. I need to learn how to integrate Conan and VC Package into my Linux. Yeah, so these things, Conan and VC Package, they go sort of hand in hand with CMake. And both of these package managers, they will have CMake scripts that you can just plug into your CMake and integrate things into. And for example, if you put in, like I've done a video on Google Test before. So if you pull in Google Test from any of these two package managers, all you have to do is just make sure you find the library of CMake, and these two things will provide those scripts, and then you basically can use the target for C-test. Yeah, if you don't like Python, then I would assume, VC package is probably the best one for you. I mean, I have like more knowledge with VC package actually. Sorry, Conan, because of my long usage of it. So like saying that I've had to go to their source code multiple times and figure out why something is not working, or even write recipes for packages that are not yet available. But yeah, both of these websites, you go into one of them and you look here for example, Pulse Audio. We should find, recipes for that library where you can just say, I require this library version 14, and then it will pull all of that automatically for you. And I assume is the same with VC package. So let's see. Hopefully it's going to have Pulse Audio. So RT Audio, no, it doesn't have Pulse Audio, which is a problem for us. So we might have to use Conan just to make the process a little bit simpler. But it has this RT Audio. What is this? I set up C++ classes that provide a common API for real-time audio input output across Linux, and it uses native ALSA, which is good. Jack Pulse Audio. Oh yeah, I mean it uses Pulse Audio, which is the actual library. One thing I haven't actually tried: does Pulse Audio work for Windows? Pulse Audio on Windows. I know it's open source. Yeah, okay. So you can build it for Windows, which is what I assume. This will do. We'll build from source. Okay. Another thing that I have to look out for as well is that I have some code that I eventually want to bring to more modern practices that was created ages ago, and that has Pulse Audio in it. So I want to make sure that it actually did work for Windows, and I am using the right library here. So I think it was here somewhere. Oh no, it was Port Audio that I used. See, even I get confused. So yeah, the reason why I'm looking for this is because Pulse Audio is like sort of like a low level library for Linux, and it does work on Windows as well. But then I realized that we may have a few issues by porting this library to Windows. However, Port Audio might be a more higher up library that may use things like Wasapi in Windows, which is the actual audio driver that comes in Windows. Port Audio is not available on Conan, which is a shame. Is it available here? Yeah, Port Audio is available on VC package. Okay, so now we have the other way around. This library is available on VC package, but not Conan. Okay, cool. And you can see here's Windows, x86 Windows, which is what we have. So it's fairly well supported, and it goes on Linux as well, I mean. And I assume it will use things like ALSA report or Pulse Audio on Linux, and then Wasapi on Windows. So let me just make sure that is actually the case. It's not taking me to the main page for it. I want to know what it uses basically. Both ASIO, okay, DirectX, okay. So you can see there are many different drivers you can use in both platforms to handle audio, and this seems to be using ASIO. Have we finished here? It's still going. Let's take a look at this, because it should be here somewhere. WSL. Okay, so still not finished, obviously. Okay, and because this library also has, it seems to have CMake support by default. Like that's what the developers do. They give you some CMake integration. It makes me think it's much easier than other libraries to integrate. Okay, so let's go with port audio again. My name is Raj. Do you do more software development on Microsoft, or more checking on what some junior? So yeah, basically I do work for Microsoft. I'm a contractor for them, so it's not really like I'm not forever an employee, if it makes sense. It's a limited time contract, which may end next year, or I may stay. I never know. But yeah, I do only software development. You don't get many, at least in my team, I don't really have many juniors, so everyone seems to know what they're doing, so we just get on with the tasks. You get a task and you do it. Let's take a look at the main page here. There you go. So the native audio APIs that uses on Windows, for example, WhatsApp is one of them. ASIO is another one, which is good. On Linux, it uses ALSA, OSS. I've not heard of this one here, as Heapy or Jack. ALSA is definitely the most popular one, so I guess it, by default uses that when you build it. And here on Microsoft Windows, it doesn't. I don't know which one is the default, but I assume it's either ASIO or Wasapi. Wasapi is the new driver API stuff that Microsoft is now using. There you go. We finally finished it, so we can continue. And this size here is fucking. Oh, it's 13 gigabytes. That's how big my my WSL was. Let's continue it. Okay, so we shut down and we exported it to that. Don't worry. Blah blah. I'm just following this guide. Hopefully, it's gonna take us somewhere. When I finish, we need to unregister distributions from C drive. By the way, I'm on Discord as well. If you just wanna voice it. If you prefer chatting like text, that's fine as well. I don't mind. Be aware that everything was stored on WSL drive. Okay. Wait, what? When we finish, we need to unregister the Linux from C drive. It will also release the disk space taken by WSL. Be aware that everything that was stored on the WSL drive will be lost, and the command won't ask for a confirmation. Okay, so now we need to call this bad boy here with our distro name. Okay, so did it free up? That is the question. It hasn't freed up yet. I kind of want to restart my PC. Well, didn't free up as much as I thought it would. But let's do something. I mean, I had the other previous backup that I'm going to absolutely delete. I'm a bit wary of doing that still. So it makes the directory here, WSL, and imports it to WSL, the Ubuntu from the backup file. Okay, so let's try this. Hopefully I haven't broken anything. So here, I'm going to delete all of this. And what I'm going to do now is obviously Empty the recycling bin. Now let's see if it freed up some space now. I mean, yeah, freed up that space, but not the one in here. I guess I have to restart for it to take effect, but, you know, we'll assume it worked. And let's run this command. And again, I need to run it from here so I can actually see the text, which is a bit shit. Into WSL. And we've got WSL too. I wish I could be in and out, but I want to try this out once and I have no experience with audio stuff. Neither do I. I mean, the only experience I have is just making some sine waves, like a pure tone. But that's why we're here. We're gonna learn that today. So I'm hoping to learn enough so I can do a video in the future. So let's reply to a text. So how is Germany working out for you? Are you enjoying that compared to Brazil? Because yeah, I'm in the UK and it's much better here, in my opinion. I'm still here, just reading something. I much rather be in the UK. Oh yeah, I mean Germany's suffering a lot now, aren't they, with the whole war stuff going on. And so is the UK. I mean, we're having a bad time here too, man. It's the same everywhere. Moved to England after bachelor's, yeah. I mean, see, for this kind of job that we're doing, like software engineering, the UK isn't bad. Germany isn't bad either. Amsterdam is not bad. But, you know, the holy grail of it all is probably the US. I mean, if you get a job in the US, you'll be making a lot of money. I heard Berlin is very good for software jobs, so. See, compared to Sao Paulo, it rains a lot in here. It rains a whole lot. So that's one of the things I don't like, but the rest is okay. Right. And let's hope for this to finish soon. And oh, I have a call. Just give me a second. Hello. It is, yeah. Who's this? Right, we're back. Yeah, nope. No US in my life, even though I got a 200k job. Yeah, I mean, that's what I think as well. I mean, I've never accepted any jobs in there because I just don't like the country, to be honest. I prefer it here, but yeah, we never know. Never know what happens. Have we finished here? Still not. I think it's gonna take a while for it to import again. So yeah, I mean, port audio seems to be a good one. I'm not gonna lie. I'm gonna start actually writing the VC package import files, so we can actually, while we're doing this, we can be, you know, a step ahead. Oh, why is it not? Oh yeah, because that's on my D drive. Hopefully there's no bad information here on my prompt. Let's make a directory. Hopefully, can you see it? Hopefully you can see it now. Yeah, I'm just gonna make a quick directory so we can start a Git project or something, and then you can maybe you can follow up in this as well if you wanna learn something. Now what should we call the project? I mean, is it a dummy project? Audio waves or something like that. Okay, so we can code this. I'm using VS Code here. I also have Visual Studio, but VS Code seems to be a lot faster on my computer, so I prefer using that. Let's make some files. I mean, we obviously need to see make lists here. Let's just call it for the project. I don't have the extension installed. Why not? Should have already have that. Okay, cool. That's 17 is not an old one, it's not a new one. Turn it off, okay. What is Pulse Audio? Is this a different Linux Pulse Audio? So yeah, I was essentially the stream, Ahmed, and thank you for joining and welcome to the stream. I was essentially going to use Pulse Audio to do some C++ audio applications, but then I realized that it may be limited or it may be difficult to get it running on Windows. I've definitely had issues building it for Windows before, so hopefully it's not the case anymore, but we're going to use Port Audio, which is a wrapper, is a higher level library compared to Pulse Audio, and that seems to work a lot better for Windows because it has support for Wasapi and ASIO. Likewise, it works on Linux as well using ALSA. I'm hoping that that's the default driver that it uses. So that's what we're going to use here. Maybe I should... Can I edit the stream? Let's have a look. So instead of... Okay, the stream, broadcast. I don't know how to edit the freaking description of it. Is this different Linux Pulse Audio? No, isn't. Yeah, it's the same Pulse Audio as you know from Linux, by the way. That's what I was intending to use, but probably not gonna do that anymore. Okay, so in here we're gonna include this stuff. I have heard of Port Audio. Someone told me it's good. I also thanks for explaining. No worries. Well, I use CLion. VS is too much sometimes, and yeah, well, the proper ID is better sometimes. Yeah. So I agree. I actually used CLion for a long time. I used CLion for nearly 3 years. I had a license for my previous job, and then I lost the license when I lost the job. Well, when I moved my job, because I decided to move myself. But for now, like Visual Studio Code seems to work, fairly well if you have all the CMake and C++ extensions, and if you attach it to your compiler as well, it has very good IntelliSense, and I don't mind that really, because it's, yeah, I mean, if I'm on Linux, I prefer using sometimes even just Vim with some plugins, and the IntelliSense in there, which I'm not sure if you guys heard of it. Let's actually see if I can show you. I forgot what it's called now. Oh, Vim IntelliSense C++. It's like a Python. It's like a Python server that uses Clang. You Complete Me. That's the one. So on Linux, if you're using just Vim, or even Visual Studio as well, like Visual Studio Code will install You Complete Me, because this is the IntelliSense on the Linux side. It's basically a Python server, as you can see here, is mostly written in Python, that will basically use Clang to, you know, read your compiler flags, and then figure out, you know, where your errors are. You know, if your code makes sense, it does that real time. And this is a very good it's a very good service to use if you're wanting to use, you know, just pure Vim or Emacs. I think it works on Emacs as well. And yeah, I mean, take a look at that if you guys want. Yeah, anything with LSP is decent. Enough is, yeah. I still use VS when I'm on Windows though. Yeah, I agree. Like, I still use Visual Studio as well. Like, my full-time job is just is developing for Windows, so I use Visual Studio all the time. Actually, I wouldn't say it's the best IDE at the moment, although Visual Studio 19 is actually pretty good nowadays. But it gets the job done, and it has very good integration with CMake, which is, you know, definitely a plus, because if you're developing cross-platform, CMake is really good. And you can actually develop for Linux using Visual Studio as well. Like, it's not, I mean, if you want to stick to one, you know, that one is free. You can use LSP. Is that the LLVM? Oh yeah, with ClangD, yeah. That's true, yeah. You can use that. However, the reason why I use You Complete Me is because, like, the setup is, in my opinion, a lot easier. Like, I just run the the setup script and it seems to work. I've never actually used them on their own myself, like LSP and ClangD. But I understand You Complete Me uses that in the, you know, in the back end. NeoVim, Sublime, almost for a year. No supports links. Sublime almost. Any editor nowadays that supports language server. Yeah, that's true. You're completely right. Every IDE that supports, you know, these IntelliSense server protocols, or just compilation servers, then it will work fine. But most people nowadays seem to use VS Code, so I thought it was worth mentioning here. You know, that's one way to get IntelliSense for C++ in VS Code fairly easily. And yeah, the only problem with VS Code is that it is, you know, they advertise it as lightweight, but it's not completely lightweight. I think it's an Electron app, isn't it? So there's still a lot of bloat in it. So it might, you know, for the lower end devices, it might still be a little bit slow compared to just using Vim or NeoVim on itself, or even Emacs, like I know some of you guys use. So yeah, but for now we're gonna stick to VS Code because it was a quick setup for me. So WSL seemed to finish importing, and let's see if where's that guide? So we're gonna, by default, use Windows. Okay, so okay, let's see if I didn't break anything. Does it still work? I'm hoping that I can just open the Ubuntu WSL here. Yeah, Electron is very slow compared. Yeah, true, it's Electron, and it's quite slow in comparison to Vim. Even on the beefy machine, you can still feel the difference, but I don't mind. Yeah, I agree. I 100% agree. Okay, so this seemed to work fine, because now I can log into root here on my WSL. So Ubuntu is installed. I just need to swap my main user. So when I log into my previous user that I created. Okay, so why did that not work? Oh, do I have to run that within WSL? Ah, yeah. So default user, I have to actually go into WSL and try that. Fuck, wrong one. There you go. Okay, so why? Oh, so this command is not found. Let's do this from here. Okay, so no, I need to. I don't know how to set the default user. Okay. WSL config. Okay, so does that work? Okay, WSL-U. That seems to work. That people seem to be doing that. Is this gonna work? Okay, so that actually starts WSL, but the thing is, I do want to make sure that it starts off normally with my user, so when I did this before, the normal command syntax is this. I didn't have to change any of the system files here on Linux. I'm not going to change that. There was a WSL command that I could just set. I don't want to change the registry either. Is it Microsoft or not? WSL set default user. No, that's the same page as before. So what do you guys develop with out of interest? I'm guessing that Ahmed, you use NeoVim, right? That's what you mentioned. And what about you, Calv? Are you still using C-Line then? So Ubuntu, it's not recognized. Okay, so that is recognized. So now we can do this. So it's just the executable name or whatever the tool is called. There you go. So now, hopefully when we do this, it should be my actual user. Notice the startup time. Yeah, seems to work. Good. Cool. So we now freed up some space in C. We migrated it to a different drive. And let's go. So yeah, let's actually begin writing all this stuff then. What I'm gonna do now is I'm gonna jump onto WSL, and I'm gonna do it from there because I prefer working on there. Okay. And hopefully you guys can see. Ooh. No magnifier, please. There you go. Okay, so if I make a directory called audio waves, that's the sweet spot for me. Yeah, I really like, as I said, I used it for 2 years, and I really do like the idea. I think it's really good. It's good because CMake support is the only thing you can use to create your projects, so it forces them to actually develop really good CMake support for it. So yeah, it's amazing. Cool. And now we're actually inside Linux, which is good. Don't save. Changes background from grey to black. I know, yeah, dude, I can't. Actually, let's fucking change that right now. It's because of the transparency, you see. It's already black. But when it, is the text color that's kind of messing it up. Does it appearance theme is dark? Use Windows theme. No, I want to change the text appearance, but it doesn't really matter now anyway because we're no longer going to use this terminal. But yeah, it's every time I look at it and I can't read my options. It's kind of shit. So okay, cool. So we are here, and I believe I already have VC package installed on this. Is it Control Alt T here? Wait, what is the terminal thing? Control Shift there. So yeah, we can use the terminal in here now. Do I have VC package installed? I believe I do though. Yeah, I do have VC package installed. It's just not a system installation, but that is fine. We can work with that. Just gonna rewrite that thing. That's supposed to be off. And let's just create an executable here. Old audio sample or audio demo or something like that. And say it just goes from the main.cpp file. Or in fact, let's create a directory called source, and then inside that we create another directory for the actual audio demo. Let's keep it nice and structured. Okay. Now inside the source, I want to create a new file called cmakeLists. That's just going to pass through to the audio demo. And then that, we're going to create another cmakeList. That's actually going to have the add executable command here for the audio demo, and that contains the main.cpp, and then we can put it, you know, here. Did it go through? No. Okay, cool. And just for compilation, let's just do this. There you go, typical hello world. And I want to see if it's going to compile now. Because we might have some tests elsewhere. Okay, so if I cmake configure, let's choose which compiler do I want to use. Probably 9.4 to be honest. Okay, cool. So configure warning. Does it build? It does build, and it goes into the build directories here. And if I go into source, audio demo, audio demo should be there. Wait, what? CMake file. There you go. Audio demo is there. Cool. So, okay, cool. So it's compiling fine. Everything goes into the build directory. Now, the first thing we need to do is to actually, let's see if we can include port audio with VC package. And I'm going to have to write a manifest file or VC package manifest, which, you know, in this file you actually say I want port audio this version here, or it has to be more than this version and no greater than this version, etc. So let's get that. So VC package.json is the name I have to give it, I believe. I'm getting up the documentation because I don't remember how to do it. I mean, last time I used it was many months ago, so. And that, I believe, has to be here. Let's see if we can just quickly grab the simplest VC package. Looks like this. Dependencies. Behavior toolchain. Okay, so we probably want something like this, to be honest. We say what the name of the project is here, the version string, port version, we don't care about that. The home page, that would be the Git repository, I guess. Description. Let's copy this and then we'll figure it out from there. These dependencies, they don't have to be text, I believe. You can have something like as JSON object where you specify the name of the dependency and then the specific version requirements, such as, it has to be more than this version or something like that. If you don't specify it, I believe it just downloads the latest and greatest one. But okay, I'm not really a fan of just leaving things unversioned, to be honest, because things can go wrong. I don't know what port version is, but let's leave it there for now. It doesn't really matter what goes in here, but we don't need any of these. Oh, there you go. That's what I meant. So port audio, and let's look at the actual documentation of this. See, I'm looking to get the actual settings for this feature list. No feature list, so it has no features. Let's just put it here. Port audio. We have no features, but we do have a versioning though. Let's read the documentation, because I want to specify the version. I want to say, always pull this version or something similar. Where's dependencies? So, okay, so dependency is an array of dependency. An array of dependency. Okay. Now, what is a dependency in this case? I'm not reading the whole documentation because I don't have time, so I'm just going to try and find it. Enter a package name or an object. There you go, a name, features, platform, a platform. Is there no versioning on it, on the dependencies? Oh, seems to be a common search. Believe it or not. Dependencies, okay. This seems to be a little bit better. I've got to make sure that we also don't play any songs that are not free here from this, outside this list. I don't want to get a strike. It seems to be in the list still. There you go. We do have a version greater than a minimum version constraint on the dependency. This field specifies the minimum version of the dependency, optionally using an n suffix to denote port version if non-zero. See also versioning. So let's have a look at the versioning for it. And I'm assuming the stream is still running, right? I don't know. Let's have a look. Right. I don't know. Yeah, it's still going. It's just because my YouTube froze there for a second and I was like, shit. So version string, content version schemes, blah blah. Ports in VC package should attempt to follow the version conventions used by package authors. Okay, so there's semver, okay. Version constraints. So this is what's in the dependencies. Okay, so name, version, more than that. VC package selects the lowest version that matches all constraints. Okay. So less than a constraint. So a less than constraint is not required. All right, I see. But what happens if they go from, let's say, let's close that, version 19.7 to 20, which will break some stuff. How do they do it? Okay, no, let's just use this version more than to whatever, you know. It's 19.7, right? So version more than, and then we've got 19.7. Yeah, so platform, Windows and static are not okay. So we don't need this, I believe, because we want it to compile for Windows and whatever else. Right, so I would assume that this is it. I mean, we can now install the dependencies and it will create me a nice little CMake integration file. So let's read at how we do that. Because I believe you have to call the executable for a VC package, right? Manifest install. Okay, this is the same page as before and doesn't have the installation content. Because the reason why I'm using this manifest mode is that, you know, VC package by default, or at least when I played with it many moons ago, it would install a dependency sort of system wide. So if you need OpenSSL, for example, then, you know, if you put that dependency on your project, you would install in your whole system, or in fact, I'm not sure if it's a whole system or just the user directory for the, you know, the VC package installation. But I just want to keep that dependency just for this project. I'm not sure if it's allowed to do that. What I'm looking for now is literally just a command for a VC package install. You can't install. Okay, yeah. No, it didn't. I was wrong. I mean, this person says that it installs libraries, I guess, on this VC package directory, but then it doesn't install anything system wide. Okay, so I was wrong there. Okay, this is what I'm looking for. Thank God I found it. Right. Oh, what is... Okay, that was weird. Right, so my VC package is actually located in... I think it's development. Okay, so install root has to be basically where we are now, so... Okay. Oh no, we are in development. I mean, keep that thought there, so let's go into the audio waves, and then we bring that back in here. I'm turning it up just a little bit so you can see. Can't spell development for some reason. Let's keep it there. And put it inside modules. Uses version and does not have a built-in baseline. So okay, let's do that. Let's look at the VC package help for baseline development, VC package help versioning. Okay, that's kind of useful. They provide all of that in here, all the help stuff. Each version, the addition has a port version, which is a non-negative integer. When ordered as a text, the port version is added as a suffix. Built-in baseline. The baseline references to a commit with the VC package repository that establishes a minimum version. Oh yeah, I do remember seeing that. A minimum version on every dependency in the graph. If no other constraints are specified, then the version will result to the baseline of the top level manifest. Alright, this is a little bit tricky because we need to find a commit from the sounds of it, of the recipe. This is becoming trickier than I thought, but we'll get there. Baselines, there you go. So baselines define a global version flow for what version will be considered. This enables top level manifests to keep entire graph of dependencies up to date. It kind of does make sense that it needs a baseline. So built-in baseline. Okay, so is it a matter of just me getting the baseline for it? Okay, so let's try that. VC package. GitHub. I think it's like a commit on the VC package. The VC package Git repository where I can just you know, it doesn't go any lower than that. Essentially, you know, all the recipes will be acquired after that baseline or on that baseline. That assume that's what it's doing from what I understand. So let's look at the commits here and then just copy the first one that we see, like this one. Okay, so if we put a built-in baseline here, does it work? Built-in baseline. Why did it not copy the commit? Okay, let's try that. Is it built-in baseline? Dependencies and expected. Okay, so maybe I've misspelled something. Built-in baseline. Ah, okay, no, this is on the top level. Okay, nah, yeah. Okay, so let's have a look. On top level built-in was not a valid commit SHA. Expected 40 lower. You can use the current commit as a baseline, which is okay. Wait, what? Did I not copy the valid commit? The commit was that. Huh. Maybe it was like the merge commit or something. But oh, yeah. What the hell am I doing? Because it wasn't valid. Let's just use the current one anyway. Okay, so now it seems to work. Now it's installing port audio, which is good. And we just gotta wait a bit and hope for no errors, otherwise we're gonna have trouble. That was a lot harder than it had to be, and sorry about that, Calv. But we're getting there. So right. Let's just wait for this, I guess. And I'll be 1 second. I need to get my phone. I'll go back. I'm back now. By the way, if you want me to share this on GitHub now, I can do it. I'm waiting for it to at least build a very simple app first. So for us to build a very simple app first before I put it on GitHub and you can build it locally. But if you want to get ahead, like I guess you can install a VC package for now. And that Barbosa guy might join us. Right. The question is, has it built? Yeah, I mean it did. So right, so it should have, from what I remember, it should have some instructions on how to actually link it to CMake, which is what we're gonna do. So the port audio provides CMake targets. Okay, target. Cool. So what can we do now? I believe before we actually do this, obviously we're gonna need this at the very top here before we include anything. And we don't need this config, just the required will do. And target link libraries, yeah. So the port audio static is what we're going to use. So it seemed to have worked fine. I assume it's not going to find it. There you go. So it's not going to find it because it doesn't know where the modules are. So if you look at here, for example, this is where we put all the modules. Is it vc package point.info? I'm trying to... Basically, I need to include the CMake stuff. There you go. So port audio is what we need to... I think this is the... Can I copy the path? Yeah, there you go. I just need to include this as the module path in CMake because it creates these modules, this module find files. So in particular, this port audio config. And this is what links it to CMake, right? So if I show you how to do that, so I believe if I go to settings, so workspace settings here, and this is something you can do on Visual Studio Code only, or if you're calling from the terminal, you can call like before you configure your project, such as, you know, when you're calling CMake the first time, you can pass in the variable -d CMake module path. And this is the directory now where all your find files will be located, essentially. So yeah. But yeah, port audio will be here. I wonder if I just pass the share directory, if it will work. But yeah. But on the on CMake, on Visual Studio Code, I think it's called CMake.build or configure arguments, configure args, and then we can pass in the stuff here. So that's the CMake module path. Let's just put that in there. So if we save this and then reconfigure the project, does it work? That's my question. So let's have a look. Support audio, but see, I could not find port audio, so it still didn't find it, and I wonder why. It should tell me what DCMake export, DCMake, whatever. See, whatever I added in there hasn't. Oh no, it did. DCMake module path. Home, blah blah. Share port audio. So why did it not work? Is it DCMake module path? I think it is. Or is it modules path? That's. Yeah, it's module path. Okay, so now we have a different issue, which I can fix. And yeah, I do apologize. It's been a while since I've not used VC package. And see, we have that here, and the path is correct. If I do on the command line, does it work? That's the question. So if I just go into cd build, make, then I pass in the VC make. Oops. I pass in that and put in that directory here. Does it find it? Also, we forgot to have the CMake minimum required here, and for version 3.15. That's a good point. Okay, so that didn't work. Find port audio, CMake. Could not find a package configuration file by port, but provided by port audio. Any of the following. The port audio config is here. Why is it not finding it? That's the. We might have to resort to Google. So VC package, manifest, integrate to CMake. Yeah, I think I've already checked this out, but it's okay. So they create a project here. DC make build, DC make toolchain. Okay, yeah. So I'd need a toolchain file, unfortunately. That's something else that we also need in VC package, and that's something I completely forgot. So yeah, let's add that. DC make toolchain file, and here we can just use. Oops, not all of this. VC package. Okay, so basically it's in home, and this is created for Windows, so I need to change all the shaping characters here. VC package scripts. Okay. I wonder if we need this the other module path now. I'm not sure if that handles it automatically. Let's take a look. Could not find toolchain file. VC package scripts. Okay, so it must be an error. It must be the wrong path then. Let's find out. So right. So what do I have here? I have home. Okay, yeah, that's right. There you go. Most of the time with this kind of errors, like, it's going to be you that made a mistake or me. So, like, when you have a path or something, always double check it, because, you know, it's a big issue. There you go. Running a VC package install. And there you go. Now, finally, after like maybe 20 minutes of debugging the shit, we've managed to actually find the package port audio, and we can actually include it in our main file here. So, and because that's one of the cool things about VC package, all you need to do is just to include that toolchain file that they provide, and it will handle all of the dependencies. It will include all of that in CMake, as long as you pass in this variable here. If you're watching, as long as you pass this variable here, as they say in the guides, it should work fine. I'm just a bit rusty on this. Oh, my video is still off. Oh, why isn't my video not coming on? There you go. So with a bit of luck, we can actually create a nice main file that will use port audio. And we need to paste that in here, I believe. I think it's find package, port audio, static, required. Or audio static. Why? I made a typo again. Oh, it's just port audio. Okay. It was just port audio. So. Right, let's see now. Yeah, good. Right, cool. So what can we do now? So let's actually pull up some code with port audio, like an example, and see if we can build it. Writing a callback function. So a callback function is what we need for the buffers to actually send data to the audio device. And this is a C style calling, so I guess this is a C library really, isn't it? So okay, so we have the input, the output, the frame count, and that. So we can read more about this in here on the documentation, but let's just copy this for now and paste it at the very top of our main CPP. And let's just, you know, for the sake of keeping me a bit sane, let's just style this a little bit better. And I can, you know, before I build this, I actually need to do my target link libraries, I think. Maybe there's a private. Is it port audio and port audio like this? Usually this is the CMake default target names. Okay, so target audio is into port audio, but the target is not defined. Okay, so the easy way to check what that should be is probably just to read the config file. CMake around this part targets. Okay, so targets is what we need. So what target is defined here? Okay, so I'm looking for the target release and target debug. Why is this so difficult to read? So it includes each of these debug and release. Isn't that a add library or something? For audio static, okay, right. Now the port audio static is the one I'm looking for. Okay, so we have a warning. Policy comp should be set before this line. Okay, maybe this is an issue with the CMake version. We're on too low. What is our version? So 3.16. So let's say we want 3.16 here. Audio demo links to some libraries for which link I must use pthread and whatever. Okay, well, let's do what? Just write port audio. Yeah, I mean, if you just write port audio, I'm not sure if that is a target. From what I can see here, let's try that. It might or might not work. Oh yeah, you're correct. You're correct. Port audio. Yeah. Thank you. That worked. However, I do believe that this is not the static version of port audio, so I would still like to keep the static one. So I don't want to redistribute the port audio libraries with my executable, you see, and that is where I guess that's where the warning is coming from, really. Okay, so let's just set this policy. I think it's something to do with pthread. Okay, so let's have a look. And just so we know what this actually is, what is this policy and what does it do? And the thing with CMake is that you can always look for the policies and see what they do. Link libraries via full path no longer produce linker search paths. The policy affects how libraries whose full paths are not known are found in the link time, but was created due to a change in CMake deals for libraries whose full paths are known. Consider the code target link libraries. CMake 2.4 and below implemented linking to libraries whose full paths are known by splitting them on the link line separate components consisting of the linker. The example might have produced something like this. After library A. In order to link library A, analysis will perform multiple link directories such as... Okay, so search multiple link directories if not found, is that correct? Unfortunately, this change can break code like this. Okay. The old behavior or policy is deprecated by definition and may be removed in future version. Okay. Alright, so basically I think that the VC package is linking to the port audio library with the full path, and CMake is complaining about it. That's why he's gonna have to set the new policy here. So we'll leave it there, and hopefully no more. Okay, so it's still policy should be set before this line. Ah, okay, no, because this is happening on the VC package toolchain file. It's even before that, so I am gonna ignore this warning for now, and then we're gonna fix it later, but yeah. Anyway, so let's continue to close all these files and then just leave our main CPP here. And we're gonna include port audio. Okay, so if we include port audio here, we should see all the definitions of that function. Let's change this type F to using, because I prefer that. Using PA stream callback. Okay, this should be fine. A little bit more modern. You can see the pstream callback is a function pointer that takes this particular inputs and outputs here. Yeah, so good. Let's continue to with the example. So before we begin, it's important to realize that the callback is a delicate place. This is because some systems perform the callback in a special thread or interrupt handler, and it's rarely treated as the same as the rest of the code. So first of all, when I read this, I'm thinking it probably runs it in a different thread concurrently to the current code, which makes sense. If you're dealing with audio, you probably want it to be done in a different thread, I guess, or the hardware, the thread that's handling that part of the hardware. For most systems, you won't be able to cause crashes making disallowed calls in the callback, but if you want your code to produce glitch-free audio, you will have to make sure you avoid function calls that may take an unbounded amount of time to execute. So this is basically saying that whatever goes in that callback, you can't throw any errors in the first place. It has to be fast, because it kind of makes sense that it's passing buffers. You know, this callback is going to be passing buffers to the audio. It's actually going to be rendering that audio and then making the sound, as you can imagine. So it has to be fast, and you probably can't use things like mutexes and stuff because they're very slow there. So that's something to keep in mind. And obviously you can't error out, so you have to write very careful code. And I'm not going to read the rest of it because I think we got the idea here. Yes, this is basically a real-time function, so you got to be very careful. But yeah, we've got a definition of it. And here's an example of a callback. And maybe we can use this code to, render some audio. So let's try that. Let's try that actually. PA test callback. Okay. So let's try and run this code actually. Let's see if we can make it work. Right, we don't actually need this thing anymore. I mean, only if we're defining some. I will keep the type there just just for now. But this is a struct. In C++, it will be called PA test data or something. This is no longer C. See, but at the same time, we're just turning everything into C++. And yeah, as in C, you have to define a type def struct and then the name of it afterwards. That's how you define structs in C. But in C++, you can just do it like this. And left phase and the right phase. I believe this represents the data on the left and right buffers, because obviously audio has, is a two-dimensional thing, three-dimensional thing. So okay, this routine will be called by the port audio engine when audio is needed. It may be called at interrupt level on some machines, so don't do anything that could mess up the system, like calling malloc o3, which is a very important thing here, because that implies we can't call vectors on it, because it internally will call malloc and free, right? So let's stick to sort of stud arrays or something like that, which will probably, are not going to call, they're just compile time arrays. So okay, so what do we have here? Input buffer, output buffer, frames per. Okay, so this is probably where we have to actually read about the definition of this callback. So let's have a look at that. Okay, so parameters input and output are either arrays or interleaved samples. If non-interleaved samples were requested using the PA non-interleaved sample format. The thing with port audio static should actually work. This might really be an issue with the versioning. Yeah, I might try out target link libraries, private static. Yeah, I'll try that. Private static. Dash static. Okay, so what does I get you? Let's see if that makes sense. 1 second. So let's look at here. So private link libraries is that. Maybe we can actually, add it here. So target link options. I mean, this is GCC, so your code will work. But I'm not sure if the dash static will work on Windows, shall we say. But we try it here because we're using GCC just to make sure that it disappears. I believe I can just do this as well because this should be a string. Target link options. Why is this not being recognized? Oh, it's audio demo, isn't it? Let's try that. Yeah, I mean, it still didn't. I mean, obviously, if I remove it, just for the sake of not having that there, let's just keep as port audio. And for now as well, I don't care if this is not a static library. Yeah, I'm just a bit wary because, this static here may work on GCC. I think it is a GCC flag, isn't it? So, well, so as soon as you go to MSVC, it'll be a different one. So in the end, we're going to end up having something like, if it's MSVC, MSVC, I can't spell today. And then we do, you do something like that there, whatever the value is. And then if it's not, then we do, this one, the target link libraries, whatever the MSVC. I think it's something like, MT debug or something like that. Sorry, MT thread static or something, threaded. I don't know what the particular flag is for MSVC, but it's something we have to figure out. For now, though, yeah, let's keep it. Let's just keep it, even if it's not statically linked. We don't really care for that now. So let's keep it as this, because the warning disappears, and I appreciate that you pointed that out. So thank you. It's really good to know that if we just put port audio here, it will work. I guess you're reading documentation as well, right? you're probably spending more time on it than me, which is definitely a good thing. I'm very low on patience for that kind of stuff. Okay, so continuing here. Yeah, so audio, this is, input and output are the audio data that goes in and outside and out from the device. Interleaved means that, left and right channels can be, you can have the first sample of left channel and the first sample of the left channel, one after the other, and that will be interleaved. Now, non-interleaved, I guess that means, the entire left or right channel first, and then the entire right, the other channel after that. So that's what this means here. And you can set an option here to make it sure that it's, either interleaved or not interleaved. Frame count, the number of sample frames to be processed by the stream callback. Okay, so however many frames are going to process, time stamps indicating the ADC capture of the first sample input. This is, I don't understand this, but we're going to take a look back at this. Flags indicating status flag indicates whether input and output have been inserted or will be dropped to overcome underflow or overflows. Okay, so whether it's gonna, I guess, drop some frames, that would be cool. The value of user supplied pointer. Okay, all right, so this is the user data, and I guess it's a void star or something. Yeah, cool. So what is this doing at the moment? So PA test data, we convert PA test data, which is this here. We can convert user data to PA test data, and that's a cast there. Not amazing in C++, modern C++, but we can change that in the future. And float, a point to float output buffer is also void star. Great, so let's convert that to a void star. Unsigned integer. Okay, so input buffer. Prevent any use variable warning. Wait, what is the input buffer? Like, I thought the input buffer is what gets passed into the device, but clearly the output buffer is the one, I guess, right? Yeah. Okay, so you write the data to output buffer. Okay, so cool. Okay, so it's just basically taking the left phase and the right phase and then passing it to the output buffer on however many frames per buffer we have here. And frame, I guess, in this particular case means a particular audio sample and generate a simple sawtooth. Okay, I like that. So it's a sawtooth wave. Yeah, by the way, sawtooth wave, there's different types of waves. For example, a sine wave will generate what we call a pure tone in audio. And it's a very sort of like really smooth note. You can also have sawtooth waves, and they all have like a certain oscillation, like a certain number of these waves per second, and that's what's going to create your frequency. So for example, 444 hertz is, I believe, like the note A. So if you have 444 of these a second, then you're going to create an A in a sawtooth format. It will sound different to a pure tone or a square wave, for example. Square wave, kind of like this, but they will all have the same tone. They all like sound like the same note because they have the same oscillations. If you create all of these, in the same number of these oscillations per second, and that's where the frequency comes from. You see, so they are doing this here, something like this. They're creating a sawtooth wave, and I can see that because, or whatever, they're iterating over this. And they are increasing 0.01 every time until it reaches 1. You see, I think audio is between... Oh, in this case, it's between -2 and 1, which is interesting. I thought it would be between -1 and 1, you see. Well, it seems to go from -1 to 1. -2 to 1. Electrical engineering oh, yeah. Sorry, I forgot that you're an engineer as well. I mean, I wish I learned more about this at uni, to be honest. Like, they didn't teach any of this in there. But it's interesting, anyway. I mean, so when the signal reaches top, drop back down, higher pitch so we can distinguish left and right. Okay, so this one will have a bigger oscillation. Okay, it's the right phase. Okay. And now how do they put it all together? Let's get that code and see. It'll be a nice challenge today to actually do a sine wave. So let's try that. We'll run this code and then try and implement a sine wave. That was my previous code that I had with port audio as well. And then we have to initialize port audio. So before making another call, port audio must call PA initialize. Okay. Have a massive go-to there. So let's run. Oh. What's PA? Why don't I have PA no error here? See, I don't have this particular value. Oh. You'll return a result of PA error. If the result is not PA error, then error has occurred. It's making me realize that this is a C library, isn't it? So I need to use C linkage in C++ headers. And there, I can't remember. There you go, extern C, that's the one. So basically, what I'm going to do here is just do this. Include errors detected based on the information provided by configuration settings. Yeah, that's the issue. Like, this is a C style library. So there are, you know, I'm just getting the code to run now, but there's a lot of things we can do to turn this into C++-ish. I mean, the easiest thing is just to be able to write wrappers for all the C style functions that we need. But yeah, you're still going to be dealing with C code. Cannot open source for audio. Okay, but port audio static does, right? So we had that before. Okay, yeah, so it has to be pretty much port audio static, I think, unfortunately. It's not declared in the scope. Yeah, so PA test data is all we need here. Okay, so that should disappear now. Okay, cool. Yeah, all these casts and stuff, it's a bit painful to watch, but it will compile. We just need to, to fix it later. Expression must be a modifiable type. Okay, so these are just float values that are kept between calls to this, okay. I see what they're doing. So they're caching the previous, well, the last called wave value for each channel into this PA test data struct here, and then they continue from there. Okay, so this kind of makes sense, yeah. And now why is this not being called? Expression must be a modifiable L type, but it is a modifiable L type. It's a pointer to this. And this is definitely the first one we get. Is there an error with this stuff here? But it is. This is definitely. So if I try and assign this like out. So what is this? Okay. Okay, that disappeared now. Yeah, because if you... Wait, is that what the code was? Does this work in C? Yeah, I mean, that's weird. They were just assigning this value to the pointer itself, not the value that the pointer refers to, which is a bit weird, but we're getting there. So we've initialized this, PA no error. Okay. You can get the text message that explains error message by passing PA. Get error text, okay. Let's copy this and turn it into C++. Okay, so PA get error, that will... What does that return? That returns a const car. Okay, so what we can do here is just do a CR, really. Oh, we can use, you know, another library. That's very good as well. Called FMT. On the VC package. And it should be a lot easier to include it now, because we've already got the good stuff up. Okay, so let's... All we have to do is, because we've already got the VC package stuff in there, all we need to do is just to put that in here, hopefully. And then we can find the package here as well. FMT required, and we also use FMT there. Now in this case, I think it's FMT-FMT. Oh, colon. Okay, cool. So that seems to work. Let's have a look. FMT format.h. Oh. Yeah, FMT basically, if you've ever done, I know you don't like Python, but the formatting in there is quite easy. And FMT is basically a C++ head, I think it's a header only project that brings all of the nice formatting to C++. So you can do something like, you know, std string here, an error message or something like that. I think I forgot to include the string there. Yeah, you can do this, and then is equals to FMT format, and then you have your error message like port audio error, and then you can have your -s there, and then you will be, you know, PA whatever this is, get error. Yeah, something like this. Or in fact, you can actually just do an std out on that. And for this, I mean, yeah, take a look at FMT if you don't know it. Yeah, it's a really good library. I used it in most of the projects that I've worked on. except a few. Use STD format. Yeah, STD format, you see, that is, I think it's a C++ 20 or 23 thing, right? Yeah, since it's 20. Yeah, MSVC, they have implemented it already. But like if you're stuck in C++ 17, for example, or a lower version than 20, you can use FMT. And I think, I may be wrong when I say this, but I think the the format header in C++ actually is FMT, is the whole of FMT. They just brought it to the standard. Yeah, there you go. You said the same thing. So, you know, in this case, we're using 17. For no reason, really. I think I just wanted to compile on my other machines as well. I know some of the compilers I have particularly won't support 20 or 23, so... Hello, Miguel. How's it going? We're doing some audio programming, Miguel. We're doing some pot audio programming. So, you know, maybe you can actually work on STD print. Yeah, I've not heard of that. Maybe I'll take a look at it. They're working on stud print for the next C++ standard. That'll be really good. Or printf as well with better API or something like that. That'll be interesting. Okay, so we have an error here. Let's try and keep going before we get tired. Must start working well. Yeah, nice. Yeah, so you've got a nice store in there, Miguel. That's good. Always learn when you have time, innit? I mean, we're using a library called Port Audio, Miguel, so we're talking about using Pulse Audio for Linux or Juice. And I realized that Juice is very big, so I was trying to find an alternative, and Port Audio is actually quite good. So you can do audio in C++, and it seems to work on Windows, Linux quite well. It is a C library though, so you're gonna have to do some C code or translate some C code, but you know. We need to terminate Port Audio as well, as it says here. So this will be at the very end before we return. I mean, if we haven't initialized it, we don't need to do anything, right? Hopefully, but if we have initialized, then let's put it here. Do I want to camel case? No, just want to... Let's keep it consistent with the rest of my code I'm going to write later. Okay, that should be fine now. If you guys want me to look at some code review or something like that, you know, just let me know. I'm free. I'm just doing this to pass time because I have nothing to do today. But I'm happy to provide some code reviews or something like that if you guys ever need that. And the printf is going to disappear. Okay, so we've initialized. We're going to do a bunch of stuff here, I guess. So this is where we're going to play the audio. Opening a stream. So now we need to open a stream to the device. So a stream. Yeah, cool. You can specify whether you want audio input or output. So we want the output audio, I think. How many channels, the data format, sample rate, etc. Opening a default stream means the default input and output devices, which saves you the trouble of getting a list of devices and choosing one from them. Okay, cool. So we're gonna open the default stream, and I hope that goes to the whatever device I'm using. So for example, I'm using the headset. Hopefully it will pick up the right one. And just give me a second. Just gonna reply to some texts. Miguel, I'm using VC package actually. The reason why is I wanted to use Conan initially, but Conan doesn't have the port audio recipe, so I'm using the VC package one because it had that. And I actually spend a good amount of time, unfortunately, with Kelv here trying to figure out what's not working. But yeah, but it took a while to fix the VC package manifest file, but we got there in the end. Now it runs in CMake and everything else. It's integrated in CMake and everything's running fine. Let's go back to this. Okay, so I'm very tempted to just copy and paste the code and change some of the stuff in the main. So static PA test data. I don't want to make it static. Okay, let's just open this stream here. I'm going to copy that. I know I'm just copying and pasting code, but I just want to actually get something working before I start making changes here. Oh man, what is this? This padding on this code. I'm gonna leave the comments there because it's probably gonna be useful. What am I doing here? No, a little bit more. Okay, so we went too much there. 1, 2, so 2 there. Right, let's keep it there. What I'm missing here is the sample rate. Sample rate in that case is 4410, which is default CD player sample rate, I think, right? So that many samples per second, I believe. Yeah, 44.1K. So should be good quality. And data, what is data in my case? Okay, so I'm just gonna... This should be here somewhere. I'm not gonna make it static. It doesn't need to be static. What is it? No, it doesn't. It doesn't need to be static. Okay, so now starting and stopping. Okay, so let's actually specify what the values are here. So let's say we start from -1, 0F and -1.0F. And this is what the starting values of the phases will be. And what's going on here? What have we failed to do? Error to open the stream. What was the error function again? It was PA get error text, right? Yeah. PA get error text. And then we pass the error here. stream get error. Okay, and then we'll pass in that error here as well. Okay, and what do we have here? We've got something that will open a stream. We've got the callback function, which obviously leads to the initial callback that they created in the example. And is that it? Do we just play it now? So let's read this. So you can communicate with a callback routine through the data structure, which is the structure that we pass in, or through global variables, using other interprocessor communication techniques. Well, please be aware that your callback functions may be called at interrupt time when your foreground process is least expecting it. So avoid sharing complex data structures that are easily corrupted, like double linked lists, and avoid using locks such as mutexes, as this causes your callback function to block and therefore drop audio. Yeah, this makes sense. Such techniques may even cause deadlocks on some platforms. Port audio will continue to call your callback and process until you stop the stream. This can be done in one of several ways. But before we do so, we want to see that some of your audio gets processed by sleeping for a few seconds. This is easy with PA sleep. Know that a variety of reasons you cannot rely on this function for accurate scheduling. So your stream may not run exactly the same amount of time as you expect, but it's good enough for our examples. Okay, so I'm not going to use this. I'm going to use this stud thread sleep for function in C++. I'm done with the C stuff. Let's go down here. So basically when we start the stream, it should already be running. What is... Okay, so why is this complaining? I don't know. Okay, so this is being complained about. I don't know why, but it seems to be recognized. So yeah, we started the stream here, and now we just have to do this thread, sleep 4, and I do believe we need the chronos as well here. Let's keep it neat and for the... How 5 seconds, I guess? Let's see. Right, so we sleep for 5 seconds while this is playing, and then we terminate it. I mean, ideally, it should be it, right? This is the entire example, I guess. Closing the stream and terminating the port audio. No, we did need to close the stream as well before we do anything. Okay, so we have PA terminate already running in here. We just need this call here now, and then okay, before we close. I think it's called PA no error, right? I'm just gonna copy and paste this because I want to be quick now. I just want to get this code running. We've been here for like nearly an hour, I think. So we're not going to return because if it doesn't close, we still need to close the library port audio from the sounds of it. Okay, cool. Right, now is the time of the truth. Can we build this? We can build it. Can we run this? That's the question. And for that, I'm going to pause the song. And I'm going to actually turn it up a little bit here so you guys can see it. And let's go to the directory where I put all this stuff, audio waves. Oh yeah, I see where you got audio waves now from, Kel. How would you get better at reading documentation? Generally, my advice would be to just, you know, look at Stack Overflow first before you read any documentation, because it might be more helpful. But documentation, dude, it depends on the stuff. Like CMake documentation is notorious for being bad and not explaining things very well, for example. However, if you look at, you know, VC package or even Conan documentation, from what I've seen today, you know, they're both fairly good. You know, there's nothing to do apart from just sitting there and reading line by line this stuff in the documentation. Really, make sure you don't skip anything. But yeah, it's difficult. always go to Stack Overflow first. I'm sure that Calv would agree as well. Okay, so audio demos here. Error opening the stream, S. So we do have an error opening the stream. Which is a bummer. Am I just doing something wrong here? Oh gosh, let's debug this because I have no idea what's going on, so... Let's create a debug. Launch JSON file. Okay, let's add the configuration before because I don't fancy writing all of that. GDB launch. Okay, into the program name. This is mostly right already. Build, and then we've got SRC, and then we've got audio demo. We don't have any arguments. We've got GDB here, and we don't need to set up commands, but you know, let's... Right, so let's see what's going on, because I want to see the value of the error, basically. I think something funny is going on there. Okay, so run this. Does not exist. SRC audio, okay. Is because it should be audio underscore demo. That also does not exist. Ah, yeah, because it should be then audio demo here as well. I think, right? Let's see. Yeah. It's always the paths, dudes. Always tell you, always the paths. Okay, so let's have a look here. Stream should be a no pointer there. Okay, so what's 99985? Does it return me some stuff? Mine is 998. Oh, this function is not returning me the text to the error. Mine is 9985. So let's have a look. Let's go back to the text here. I was hoping to get some audio, but... Oops. That wasn't needed there. It's interesting. I have no idea what's going on, but if you guys have any ideas, let me know. Okay, so that gets created correctly, obviously. Data is there. And that is that's still no point to that stream. Error opening the stream. Right, no, I think I need the message, so I need to figure out why it's not. What this is printing. Returns a const car star. Why is FMT not printing that error? FMT format. Let's stop running this for a second. I'm just put it into a string. Deinitialize it. It's just device unavailable. That's why. So my device is unavailable. Okay, so that's probably something to do with me running this on poor audio. So I probably need to install to allow the sound really. Okay, let's try this fix. Hopefully it works. Yeah, so basically WSL is not, it doesn't have a device in WSL because it's, well, the Linux kernel in Windows doesn't really have audio devices to start with. So I guess you got to enable pulse audio on the Linux side of things. So that's what I'm going to do. And that's the error we're getting here. I mean, we have no device basically, device unavailable. So let's see if we can fix that really quickly. I need to do, before I do any of that, let me change it to so I'm just fixing stuff in the background here, but I don't want to all the particular details. Hello, Sapphirose. How's it going? We're doing some port audio programming here, and now I'm trying to basically fix the well, to enable audio from WSL to Windows or Linux to Windows, which is turning to be a pain, but we'll get there in the end. Okay, so pulse audio on Windows. Oh, this is going to be a pain. I'm also good, Sapphirose. Just trying to get this code example to work, really. Load module. Create config. Do I want to install pulse audio on Windows though? Or is it easier for me to just not do this on... Thank you. Thank you, Sapphirose. I do need luck at the moment. I thought that pulse audio would be enabled on WSL by default, but maybe we'll have to move on to Linux, Windows development here, and use Wasapi. Yeah, so WSL2 doesn't have direct access to most hardware devices, so it's no surprise that the mic is failing. WSL does not support audio. Okay. I think, guys, what we're going to do is we're going to open the project on Windows and then just, just run it from there, to be honest. So let's do that. So let's set up a Git repository so you can push everything into it. I'm going to set it up here. Okay, so maybe we do vim git ignore or something. I don't want to push the build file, so let me just go to... I think I just have to do build, right? Or something like that. And also, I don't want to push the .vs code. Okay, so yeah, good. So git add everything now. No, yeah. Reset everything and also change this so we don't include the module. There you go. Good. Now it's just what we actually need to include. So I was basically writing a git ignore to ignore some of the directories that Visual Studio creates here, or what CMake creates, which is, you know, VS Code, build, and also the VC package 1 that's here. Okay, I'm gonna stop doing this, and let's run everything on Windows now. Hopefully, with a bit of luck, we'll be running everything back in about 10 minutes. Okay, where's my git Ooh, where did I... I'm just copying and pasting everything here. Okay, so we've got a repository here, so I can, you know, say goodbye to this WSL stuff. It doesn't have access to the audio devices, unfortunately. And I have no idea what I did here on the magnifier, so let's... And let's clone this now, so we're open and running on Windows. So what are you guys up to in this afternoon? Well, for me it's afternoon anyway. Okay, so... Now, do I have VC package installed here? I do. Great. Can I upgrade VC package before? I'm just going to upgrade VC package before I do anything. Okay, so we've updated VC package. Now we can go into audio. And I need to know the commands that I use to install all the VC package stuff. It will be very quick, I promise, guys. We'll get back to it very quickly. Okay, so if I bring... There you go, this is what I wanted. Something like this. Okay, so we're doing that, and then we also want to... Oh my god, this is the coloring that's screwing me up. There you go, better. And what we do have here is development, audio, waves, I think it is, module. Okay, so it's installing everything now, all the dependencies, that is port audio and FMT. And it should be good in a second, right? Maybe not. Baseline exists on disk, but not in... Okay, so it's git pull and fetching. Okay, so... Let's pull the repository again and try and upgrade it. Yeah, this is the whole step of upgrading VC package. All you have to do is just pull to the latest master, I think, or main. Because there's no releases for it, you just pull the latest one. They live on the head, I think. That's what they say. And now we can do the VC package, the bootstrap, whatever. Okay, let's see if it goes through now. Please work. There you go, it seems to be working now. And again, this is pulling port audio and also FMT, which is not very big. By the way, Safi Rose, if you're not joined yet, you can join the Discord. I'm happy to provide help and stuff with coding. Oh, potential thread, compiler ID. It's not a thread, it's just CMake. Amazing. While detecting compiler application, VC package is enabled to detect that. No, please, just work. Is it gonna do it again? So yeah, if you're interested in getting some help or something from us, please join in Discord. You can find it on the description of the channel. I mean the channel about page. Bro, do I really have to like stop over here or something for a bit? Really not recommended, but let's do that. Oh yeah. Wait, Sapphirose, which are you already in the Discord? Sorry, I think you might have a different name in there then. Oh, you might be Barbosa, right? Is that your name in there? If so, welcome, because yeah. I had no idea. Like, I thought you just a random person that joined the chat, you see. Okay, now it's all compiled. What we need to do is get that toolchain, the toolchain file, which will be... Okay, so now at this stage we can just actually open the project. And let's compile it with, I don't know, Visual Studio 2019. AMD 64, I guess. Okay, so we're there. And we do need to set the settings for the workspace. CMake. This is not what I wanted. Configuration arguments. Okay, so that is what we want. Can't remember the exact path to it. There you go. This is what we need. Okay, is this gonna run now? So let's configure. It's using Ninja as a generator. I can't find your Discord. Yeah, is that... You're Barbosa, right? Oh, Sapphirose, okay, right. No, you knew. Yeah, well, welcome to the Discord in that case. Oh yeah, thank you, Kelv. You did, yeah, brought someone in. That's pretty good. I mean, this is still the second stream, so like it'll be more interesting from now on once I like figure out how this whole stream thing works. Could not create name generator for Visual Studio. Like, why? Okay, let's change the kit. Select kit. Let's go to AMD 64. Okay, and now let's try and configure. Okay. Yeah, thank you. Thank you for joining us, Afiroz. I'm sure that I'm more than welcomed. I'm more than happy to help with any like programming queries or anything like that. So just post it in the chat or whatever. I would massively appreciate that. And like a bigger thank you to Kelv as well. Thank you, Kelv, because you helping out massively. Right. Okay, so we can build it, I guess. Let's try and build it. And this time it shouldn't fail, hopefully. Do I know any other languages rather than C++? Yeah, I do a bit of Go. Recently, I do a lot of web dev for personal projects and stuff. And I also, I know Python a bit. And yeah, I mean, my main language is C++, but I do dabble with other stuff like PowerShell and Shell and Bash and stuff for scripting and these languages that I've mentioned. So, but I don't know many. I don't know many, unfortunately. So it's saying here that we cannot open for audio static. And this may be due to that issue we had. What about you? What languages do you know? What do you guys program in? Is this gonna work now? Okay, so the build finished. I have to change that to port audio, which is something I need to see later. But yeah, I mean, first of all, let's actually try and debug this to see if if it works fine. Okay, so C++ is not already installed here. Let's install. I learned C++ years ago. I'm back to school in web dev, learning PHP, JavaScript, HTML, and CSS. That's cool. Yeah, that's a nice stack. C++ for the very sort of bare metal systems engineering, and then the rest of it like mostly web dev stuff. That's really cool. I wish I knew PHP better. I know a little bit of PHP as well. My blog is currently in like WordPress. And I've used WordPress for many years. So like I've always dabbled in it, like to make plugins and stuff. But I don't know it that well, if it makes sense. I wish I knew better. Okay, so I think I have to restart this for it to show up now. I got a text here. 1 second. One second. Learning C++ was the best thing I've ever done. Every other language is just a matter of syntax. Yeah, that's true. Yeah, apart from the old ones. I mean, once you go to Fortran, assembly, and that kind of stuff, it's it's no longer the same. I did a bit of assembly too. Yeah. I mean, the only assembly language I've done about a year or so was the 68K, the 68K assembly code, which obviously is not used anymore because that's a very old compiler, but it was for things like the Mega Drive or the Sega, I think Sega Genesis, right, or Mega Drive in Brazil that we called it. So that had a 68K. That's something that we learned, in university, and I did a bit extra as well on it. So let's see if we can launch that JSON file now. Why can't I not run C++ debug here? Do I have to install an extension, which is a bit interesting. Okay, so why? Do I have CMake as well installed? I think I do, right? CMake tools, CMake language. It's interesting, like... Okay, cool. There you go, found it. There's an amazing web dev course on Coursera by Meta, both front end and back end. I just don't know whether it's free for everyone. Oh, that sounds really cool. I'm gonna take a look at that. Right. Guys, I need to make a call. I'll be right back in like 2 seconds, but I'll leave the music running here if you wanna listen to it. And then we'll sort out this debug. I think it should be working out on Windows though once I debug it, because now it should have access to the audio driver. But oh, there you go. I'm back, guys. Right, so let's see what we. Okay, so this is, we want to basically debug the audio demo. Yeah. Oh. And the program name, it's in workspace. And where are we? We're in build. And then we will be on x64, I guess? Oh no. Is it going to audio demo? Debug, okay. So basically, SRC, audio demo, debug, audio demo. I don't want to debug with GDB. It will be something like Windows, right? Okay. I have no fucking clue what just happened here, but let's undo this and do it again. So C++ and a Windows launch. Okay, that is better. That should trigger the MSVC compiler, actually. Build, and then we've got audio, or SRC, audio demo. And then we have debug, audio demo again. And that is it, hopefully. Okay, let's have a look at that now. So, shall we? Definitely a lot of stuff happening, but I don't really see much going on. But it's nice that it's working after a while. That's the important thing. He finds the device this time. Right. Oh, my camera's off still. Sorry, guys. Right. So it's just not playing. Why is it not playing? Do I have to do anything else here that we forgot to? Starting, stopping, aborting. P8 start stream. Okay, so maybe I forgot about this. I opened the stream, but I didn't actually start it, which is, is on me. So see, I opened it here. Stream error. I opened it there. Okay, cool. Let's bring this code in. Start stream error, and then we have stream there. And if the start stream error not the same as PA error, yeah, no error, right? And we're going to do the same thing here. Okay, so error message, we've got that. Error starting the stream. Okay, so now we can also stop the stream, I guess, after, right? So we're gonna do it right here with this function. Oops, there you go. And the same thing here, same code. We're actually not gonna return here. We're not gonna return it here either. No, let's return it for now. I know it's not correct to do that because we still need to close. We still need to close port audio. But on starting and stopping. Okay, so now let's hope that this works now. Stop stream error. Stop stream error there. And stop stream. Right. Let's compile it all again. Now let's see if we can run this. Stop the previous. And I'm going to pause the music here because I think it's actually going to output something. Or maybe not. Maybe not. What happened? So stream error. So if he goes through the start stream error, this is what we really care about. I mean, it seems to be running. I mean, there you go. Start stream error. What is the error in this case? Can we see the value, please? No. Okay. So we need to read all the messages. I need to fix all this format stuff because it apparently doesn't take the const char star very well. Okay, let's compile again. There's a lot of fireworks going on there behind me, and I'm really sorry. Okay, hopefully you guys can hear that. It seemed to work. I don't like the way it sounds. It sounds very choppy still. And I don't know why. It shouldn't be like this. But, you know, we're getting somewhere. Let's try and run it again. I'm very sorry about the noise, but this is what apparently as a square wave sounds like, which is not quite right. It's not quite right at all. So maybe something we can do here is increment it by a little bit more. Essentially increasing the yeah, it does work. It does work. Right. Yeah, so that's what we're going to do. We're going to increase these by, I don't know, 0.6, whatever, every time. 0.006. Now let's see what it sounds like when we do that. And there you go, Cal. Finally, we got some audio. I mean, it's been fucking, like, maybe 2 hours now. What sample rate are you sampling at? So it's 44.1K, I think. That's what I open on the stream. That's what it's here. So it was in the demo code. I didn't change that. So let's see if we hear something better this time. There you go. That sounds nicer now, doesn't it? Let's try and play an A note now. So A note frequency. I think it's 40. Okay, so A4 is 444 oscillations per second. So like, how do we translate that into these values here that we want to essentially increment by? Yeah, it's better. It's because of the oscillations were too low for the audio to even pick it up. So I think it fails. But it sounds better now. And essentially, these values, what we increase each channel by on every sort of iteration, every sample. So if you think about it, I mean, let's get a whiteboard up here, shall we? Or even paint. Paint will do. I know you guys probably hate Windows, but we have some sort of like sampling graph there. So what we want to do is essentially make sure that, oh, why did it change it now? And this is what we're doing every time. So we got a sawtooth wave there, and it's going like that, and another one that kind of goes like that as well. That's what the code is doing for each channel, right? It's creating this. What we want to make sure is that, the amount of these waves that we have per second. 1 second, guys. Sorry. Just replying to some text from my other business. I'm really sorry about that. So yeah, we want to make sure that we have, I think it's 440 or however many of these per second that we. This is terrible. Who made this app? Oh my god, this is even worse. That is okay. We want to make sure that we have 440 of these per second, and per second we have essentially got, these are the number of samples here. So we want to make sure that, in all those 44.1K samples that we have, we're going to have exactly 440. So how do we do that? Well, we need to figure out how many how many samples really one of these lines has to take. So that is very easy. So we take that for the number of total samples in a second, which is 4 like this, I think, right? Yeah, and divided by 440. So that's how many samples on average a sawtooth should take. So if and we're increasing that every time. So yeah, so what do we do here? So we want to make sure that after we increase each of these left phase and right phases 100 times, it will reset. Okay, and okay, so basically we have the actual sort of amplitude of the wave here. If you look at it, it starts from -2. Is that right? Yeah, it starts from -2 and it goes up to 1. So it's actually 3. So we want to make sure that we have, once you increase it by 100 times, it does a whole unit of 3 essentially. So in this case, I'll put the maths down in a bit, but I think if we change it to something like this, what was it supposed to be? 100.82. That will make it you know, it should be very close to 0.03, which is what we had in the first place, isn't it? So let's try that. So if we just put 0.03, that is that should give us an A, at least, on both of them. But I know it's going to sound shit because it did sound bad before already. So let's have a look at this. Is it 0.03? Did I not? Yeah, 0.03-ish. It's actually 299, but oh well. Let's cancel this one. Okay, so that's a very low A, and it's less choppy this time because both the right and left channels have the same wave essentially, which makes it sound a little bit nicer. So what we can do is, you know, let's say we want to play arbitrary notes, right? So arbitrary notes, so you take in the frequency, right? So let's put an int on frequency here. And, you know, for now, on our test data, we had something like, you know, 440 to play an A, right? So let's translate that maths into here. Or in fact, let's even better than this. Let's say, you know, the step. Let's hold the step, and the step is going to be the amount we add each sample by every time, you know, it creates a new sample here, such that we have the note that we want. So now, you know, for A that would be 0.03, right? So we basically want to calculate this number here. So how did we reach this calculation in the first place? So we have the total number of samples divided by that frequency, right? Which was, in our case, it was 440, and this is, you know, this is how many samples a sawtooth wave should take. And also, you know, we want to get the right amount of each step. So essentially, what we do time is we do the amplitude divided by the number of samples that we should have, because basically once you create this amount of samples here, you're going to end up with the full amplitude, and that's what we want. So our amplitude in this case is a fixed value. I think it's 3, right? So -1 to -2 to 1 in this particular case. So it's, you know, it's going to be this, right? So now it's even simpler. Oh, I actually forgot to give it a name. It's even simpler for us to create any sort of note here. So, you know, you can even do a const float here. And I know that I may be rambling a bit, but it does work in the end, trust me. So the frequency we want to play at is 440, right? So essentially, we just put the frequency here because all the other values, they are kind of fixed for us, really. Like, we can't change the amplitude. I think that's, you know, it's supposed to be 3 from the looks of things, and the sample rate we don't really change in the runtime. So the only thing we change is the frequency. So if we just put that, you know, the step here, and then we turn that step, you know, we put the data dot step here. This should be fairly, you know, it should still work. So in this particular case, it's anything that we want to play, right? So let's run it, and then we should still get an A here. This is going to get interesting soon, I promise. Okay. I know that your ears are probably really sort of tired of listening to this now, but yeah. But what's important now is that, like, if I look at the actual notes here, no frequencies. So, you know, we've got A4, I think it was, A4. I was a 440, but I can play a D now, which is 293.66. And might have to actually change this because the frequency is not quite. Let's actually go up, because the lower frequencies we get, like the worse it's going to sound actually from what I can tell from experience. So if we go up to a D here, so 587.33. So 587.33, and that will play as a D now, right? That's what we expect. That's what I expect it to do. So let's have a look now. And again, this is going to run the. It just takes a while, doesn't it? There you go. So that was 5 seconds of the note D playing for you guys. Let's actually say we want to play, I don't know, any note in any, say we have an array of notes, an array of times, and we want to play each note for that specific amount of time, right? So that let's get there, right? So, what would be a nice audio to play? Either like something like Mario or something like that, right? So let's get a note for those. Actually, Space Odyssey is a good. Space Odyssey? How'd you spell Odyssey? I can't spell Odyssey for. This one here. Let's see if we can play this one. That would be cool.
It's kept secret, just like the Campbells.
If you just bear with me until there's. There you go. So let's try and play this, shall we? Firstly, let's actually look at the notes that we need, because I'm not going to implement all the notes. Space Odyssey notes. I'm sure it's some chords, so it's going to have multiple notes, which is going to, make things a little bit more difficult, but we can get there. I just want a simple note, like. Space Odyssey theme notes, maybe. See, I don't want the entire music sheet. I just want to know like the notes. Piano letter notes, okay. G, C. Okay, so that is a little bit better, because we know we've got a C here, a high C, and then okay. Let's try and get that working. So we need a C, we need a G, and we need a C again, and they're both on the same octaves, I think. So let's see if we can get a note. Frequencies online, where we can actually play some of the notes as well. That'll be interesting, because I want to implement this in C++. No, I can I still speak Portuguese? Yeah, no, I can still speak Portuguese. Eu falo português fluentemente. 1 second, guys. There's another call, and I will just turn off my mic while I give this call. I'll be right. So we're back now. So let's see. This is not quite what I want either. I just want like a little piano line, you know what I mean? Just so we can actually play with the notes and see which ones we need. So it was a G, it was a C here, and a G. It was, yeah, so these are the notes we needed. We needed a C and then a G, and then a C again. Oh, sorry. Okay, cool. So that's what we can get. C, D, and then an E and D flat. D flat, right? Or D sharp, or one of those. But we will. I only speak German and English. I forgot most of my PT. Yeah, I mean, I said I can speak Portuguese well, which I can, but I forgot most of it as well. So when I'm talking to a Brazilian person, for example, like, dude, sometimes the words just like disappear from my head, and I have no idea. So. But you know, I talk to my parents and stuff. Like I'm still talking to them on the phone right now as we speak. But yeah. Sorry, that was another call. But yeah, here we are now. So just 1 second, guys. I'm just testing something. Right. So essentially, let's just open a notepad here. So I need the C on some octave, and then we need the highest, the G in the same octave, and then a C on the octave above. Let's just put that in now. And then what do we need? We need an E and the same octave as that, and an E flat and the same octave as that. Okay, so the reason why I'm doing all of this, it'll become very clear. So like what I want to do is basically create a structure here somewhere. And let's say, you know, it's just above the main. So we have a struct called a note or something like that, right? And we can have a frequency on that note, so a float frequency. And then maybe an enum that defines that. I don't have people back there, so Portuguese has been part of my 5 years. Yeah, I mean, I still have family back in Brazil, but I have been away from Brazil since 2009, so like the whole 13 years. So you can imagine how little I know Portuguese now, because you know I just don't speak it anymore that you know that often. So we may not need this enum class, but no enum or something. And no frequency. I don't like putting it. Let's say we have, in this case, we need a C. Let's put C1. We also need a G in the same octave, and then we need a C in another octave. And I think we need an E, I believe. E in the other octave, and an E flat in the other octave. So those are all the notes that we need, right? And obviously I forgot to do this. Yeah. I'm not sure if you guys can read it very well, but let's say that now we need, yeah, we have that note there. So the note identifier, or the ID or something like that. And basically what we want is like a vector of these things inside here so we can play them, right? So we want to say like play this note, or even like let's call it no ID here, because then we can just name this as no. And as well as the frequency, we can have a time. So we can say we play this for the same, you know, for this number of milliseconds or something like that, you see. And let's try and do that. Okay, so how can we do this? First of all, before we start the stream, let's do it at the very top here. So before we even initialize anything, let's do a stud vector or something of no. And then we have my nodes here. So, you know, space Odyssey, I think it's called. Oh, Odyssey. And this will be my vector, or even better, an array here. And then we can add the array at the very top. And for now, I'm just gonna say we need like 8 of them or something, or 7. And then in here, I can actually do my notes. So no ID will be note ID, and C1. The frequency of that is 440. So yeah, we don't need the 2 of them because we've got the ID. We know the frequency that it should be, but you know, let's just say let's just keep that here for now, and then we can change it later. Then let's say 1.5 seconds, and yeah, we'll do the same thing. 10. Okay, so it was a note, it's a G there, then a C2, and then an E2, and then an EB. Okay, and now I just gotta like match these things here. So oh, it's not 1.5 seconds, it's in milliseconds, right? So I need to do this. And let's say we keep this for 750, so half of the time, the last 2. I promise it's going to get a little bit interesting soon. What is the issue here? Too many initializers. Okay, no, it's not. I just forgot to add the initializer list. Okay, so that we're fine now. So we've got a const array here. Couldn't even be const expert, really. Const expert static. Yeah, I mean, let's just put it out here. So we're not going to change it in the program, right? And then we just move it down a bit. Okay, so essentially we have all the nodes, and we just need to match the frequencies now. So where was that neat little note frequencies that we had here? Note frequencies, no frequencies. Okay. So say, you know, C4 was the one we had before, and that was a little bit low, wasn't it? Because it was 440. So let's start with this one. So 423. This is the value here for the C. And it should really be a thing. And then a G after that, which is in the same octave. Or just one above, actually. It wasn't the same octave. And we want a G there with this frequency. And then the next C up there. We have the C. What was the C? 523. Well, now we have this one. This one, and then we have E and E flat. So E